Alright, in this lesson, we're going to be covering all the different parameters that we have inside of a K-actor more thoroughly.
Okay.
Because, I mean, to be frank, the parameters are important.
Okay, well, you can be Frank. I'll continue to be Zach. And no, I'm just kidding. In the last lesson we had a look at, just maybe 2 or 3 of the actual parameters to a karma actor. But they managed to pull off some really cool effects inside of our level.
That's right. So if you know all of the parameters, I mean, the power at your fingertips is a lot more.
Sure.
So let's jump in. Let's go to the K-actor properties of our barrel. And let's go under Karma, under our K-params, our Karma parameters, and finally Karma parameters. So many Karma parameters. And here we have B high detail only. Now we covered this one in the last lesson.
Right.
So let's jump down to BK allow rotate. Now this one isn't really relevant unless we have BK stay upright set to true.
Okay.
Now if this is set to true with that BK stay upright,
sure,
then our object is going to attempt to stay upright at all times.
Hence the name.
Hence the name.
Yeah.
There's similarities.
Yeah, that's a rough one.
Yeah, it's rough. So with that set to true, and this one also set to true, it's going to allow our object to spin in the z-axis while trying to keep it upright.
I see. So it's not going to. It's going to attempt to keep it from tipping over. But if you have it set to allow rotate, then it will spin around in the z-axis, kind of like just spinning around, kind of like a top.
That's right.
Cool.
So below that we have the BK double tick rate. What this is going to do is the physics engine will actually. Well, in this case, Unreal, will be running the physics engine twice as many times so that it's more accurate, and it'll be a lot slower.
So it's going to be looking for collisions twice as often as normal.
That's right.
Okay.
So if that's set to true, though, however, we must keep another thing in mind, because this is very important. If one of our objects is set to, the double tick rate is set to false, and another object, say this bottom barrel, is set to true, then there could be discrepancies in the collision detection.
Sure, because you could have one object, like maybe if those 2 objects collide, we have one where it's set to true, the other one where it's set to false. The one where this is set to true, where double tick rate is set to true, it could detect the collision, but the other one might not, because it could be in between calculations at the time.
That's right.
So you get some really unreliable results as far as collisions go if you have 2 separate values for this on 2 objects.
That's right. So just to keep that in mind.
Right.
Below that we have the BK non-spherical inertia. What this is going to do is set the accuracy, if you will, of calculation of our inertia.
Okay.
So if it's set to false, it's going to be quite a bit faster. If it's set to true, it's going to be using a different calculation method, and it'll be a lot slower.
Okay, but a little more accurate.
Right.
Cool.
Below that we have the BK stay upright, which we already described in detail. And below that...
What was that? That was BK... Okay, you just talked really fast. I'm sorry.
That was really fast.
BK stay upright.
So, below that, which is BK stay upright.
Oh, that's so much nicer. You gotta remember your radio voice.
Yeah, that's right. Under that, we have the K-actor gravity scale.
Sure.
So this is a multiplier. This is going to multiply the global gravity, if you will, and make it faster or slower, depending on what you set it to.
Well, really, that's hence the name, because what you're doing, basically, is scaling gravity by this multiplier.
Right. So a higher number is going to be higher gravity.
Sure.
So below that, we have K angular damping. As you can see, the default is set to 0.2, and the reason for that is it's going to be, if there's a rotation on our object, it's going to be slowing down the rotation by a certain amount. In this case, we have 0.2, but that's just a value. Right. So it's going to be slowing it down to an eventual stop. If you had it to 0, it would just kind of spin forever and ever and never really stop.
Exactly, and that's going to look really... That's not going to look very convincing. It's very unreal. Let's not use that term. But it won't look very realistic. I mean, you want your levels to look at least semi-convincing.
That's right.
And if you have a form of perpetual motion, well, that just doesn't look right.
Exactly.
When you see something like maybe our barrel, for instance, maybe we had a barrel that would kind of fell over and it was just spinning its way across the ground. If that never stopped, if it just kept spinning, no matter how long we were in the level, then that would eventually look kind of funny.
Yeah, it sure would. So below that, we have the K buoyancy. Now this is controlling how our object floats inside of in water, how it reacts in water.
Right.
So if it's 0, it's going to sink right to the bottom of the water. The water has no effect on it whatsoever.
Okay.
If it's set to 1, it's going to free fall into the water, and depending on how fast it went into the water, it may go a certain distance, but after it stops, it's going to stay at where it stopped. It's not going to go up or down.
So theoretically, it could fall to the bottom, but it's eventually going to float back up and hover in the middle of the water.
Well, actually, in this case, if it's set to 1, if it drops all the way to the bottom, it's going to stay at the bottom.
Okay.
If you set it to, like, say, 1.5, it would start eventually floating back up.
Ah, so 1 is actually going to achieve sort of a neutral buoyancy.
That's right.
Very cool.
So if you wanted to continue going up, like wood, for instance, you would set it to like 1.2 or 1.5.
Nice.
K linear damping is very similar to K angular damping, but the only difference is that it works on translations.
Right, so you're resisting motion now instead of actual rotation.
Angular rotation, right.
Okay.
So under that we have K mass, which is also a multiplier. And this is not the accurate mass of our object. The mass is actually calculated from the volume of the object, but this is going to sort of multiply it.
Sure, well, I mean...
Make it heavier or lighter.
Okay.
Or make the mass more or less.
I gotcha. Cool.
And below that we have K start angular velocity. And what this is going to be doing is actually setting an initial angle for when our object is actually initialized, when it's started, either at when the level is first started or when it's shot.
Okay, well, you say like an initial angle. Do you mean like an angle velocity?
Right, an angle velocity.
Okay, so we actually have motion going on here.
Exactly. So we could have motion on X, Y, or Z.
So can I just take that and set it to maybe 50 and see some rotation?
Well, you could, but it would be very small amounts of rotation.
Okay.
The way it works is you would have 65,535 is actually 1 second, 1 revolution per second.
Wow, that's a high number.
That's quite a high number. So let's actually set this to a number just so we can see it.
Sure.
Let's set this to maybe 60,000.
All right.
That's all right value.
So that'd be just a little bit less than 1 full rotation a second.
That's right. So that's pretty much the K-start angular velocity, and underneath that we do have the K-start enable, but we cover that.
Okay.
Underneath that we have the K-start linear velocity, which does the same thing as up here, but it's just on translations in X, Y, and Z.
Sure. So this is actually going to be moving our specific object around as soon as the simulation begins.
Right. So that's really the same thing. We don't actually want to set it to anything in this case, so let's just drop that out. And here we have the K velocity drop below threshold. Now, what this is doing is it's kind of complicated, but it's going to trigger a function that you would have to code, and if it goes below the threshold that's set here, it's going to call that function.
Okay, and that function can really be anything that you want.
You can let it do anything if you want.
But you have to actually code it in. There's no like preset that you can just sling in there.
That's